Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azfar bin Yeop Kamal, 1626921. I'll be presenting to you on my final year project 1 on the topic of bridge analysis of an embankment of dam. So first, I'll be showing you my presentation outline. First, introduction, problem statement and objective of the study. Second, literature review. I'll be showing you my findings on the bridge modeling software available in the industry, HEC RAS and HEC HMS, and also their strengths and weaknesses. Third, proposed methodology. I'll be showing you my framework of the study and why I chose HEC RAS. Finally, my conclusion, future work and Gantt chart for my FYP 2. First, introduction. Problem statement. Dams offer a lot of benefit to nature and humankind. Such benefits are supplying water for irrigation, water supply for domestic and industrial use, hydropower generation, and also dam structure are used for flood control and drought mitigation. However, dam structure are exposed to the risk of failure. Such cases occurs in South Fork Dam, USA, and also in Nanak Sagar Dam in India. This catastrophic disaster leads to the loss of human life and economic asset. Objective. My first objective is to study the bridge modeling software available in the industry. Next, to construct a critical discussion between HEC RAS and HEC HMS model. And lastly, to analyze the bridge of an embankment of dam. Next is literature review. So in this study, I have found 5 bridge models to be studied. So first is HEC RAS, Hydrologic Engineering Center River Analysis System. This is a computer program that's modeled the hydraulic of water flow, developed by the US Army Corps of Engineers in 1995. It aids the hydraulic engineer in channel flow analysis and floodplain determination. Secondly, we have HEC HMS, Hydrologic Engineering Center Hydrologic Modeling System. It is designed to simulate the precipitation runoff processes of dendritic drainage basin. It is developed by the US Army Corps of Engineers in 1992. HEC HMS is a generalized modeling system capable of representing many different watersheds. Thirdly, we have NWS FLD WAV, or National Weather Service flood wave. It is a hydraulic routing model that computes the outflow hydrograph from a dam. It is a combination of NWS dam break and NWS dynamic wave. Fourthly, we have Embryo model, which provide a probabilistic representation of variability in embankment material properties. Last but not least, we have Make-Bridge model. Make-Bridge model apply probabilistic theory on traditional deterministic and dam bridge approach. It also create dam bridge outputs that correlate bridge discharges with probability of occurrences. Next, I'll be explaining on Hydrologic Engineering Center River Analysis System. Amongst its hydraulic analysis components are steady flow water surface profile, unsteady flow simulation, movable boundary sediment transport, water quality analysis. HEC RAS comes with HEC GeoRAS, which is a collection of GIS utility, in which GIS stands for Geographic Information System. Then it will be processed its geospatial data in ArcGIS, and then it's prepare geometric data for importing and simulate process result exported from HEC RAS. Next is strength and weaknesses. Its strength is that it is capable of one-dimensional and two-dimensional modeling computation, and it is also have an analysis of bridge score estimation. Its limitation or weakness is that it has a limit of up to 30 degrees for modeling and is unable to account for steep slopes exceeding 10%. And it also mainly support one-dimensional modeling. Next, I'll be explaining about Hydrologic Engineering Center Hydrologic Modeling System, HEC HMS. Its hydrologic analysis component are forecasting stream flow, deep area analysis, sediment and water quality analysis. It can also perform hydraulic analysis such as hydraulic routing. HEC HMS also comes with HEC Geo HMS, in which it is a geospatial hydrology toolkit. It prepares data for HEC HMS simulation, and it also provides estimation of hydrological parameters of physical features for watershed and streams. Next, it's strength and weakness of HEC and HEC HMS models. So it has a strength of, it is compatible with other HEC programs, and it also capable of modeling evapotranspiration. Its weaknesses is that it is unable to model branching or looping stream networks, and it also cannot model backwater in the stream network. Third, proposed methodology. So this is my framework for the study. First, we have to identify the problem statement which leads to the study of HEC RAS and HEC HMS. Next, we have to do a desktop study of previous researchers or previous studies or users of HEC RAS and HEC HMS to achieve our literature review. Next, we have to obtain our secondary data which can be collected by previous researchers, industrial works, and even local data from open source or supervisor. Next, combining and analyzing data. Next is conclusion and recommendation. For obtaining secondary data, that data is collected for the use of HEC-RAS. So why I choose HEC-RAS? HEC-RAS has a lot more capabilities and has a lot more abundance of data. It has an updated software, and it is widely used worldwide. So HEC-RAS offers a lot more analysis compared to HEC-HMS, and it also able to compute one-dimensional and two-dimensional modeling. HEC-RAS had a lot of local data which can be obtained by open source or from my supervisor, and most of real study case refer to the bridge model of HEC-RAS. HEC-RAS 6.0 is the latest version, and it is compatible with Windows 10 operating system, and it is also free for installation. HEC-RAS is widely used worldwide, so sometimes users share their tips and tricks, and this made learning of HEC-RAS more simple and more easier. Conclusion for FYP 1. I can conclude FYP 1 in 3 main points. First, bridge analysis by bridge model is more efficient. Bridge model is the complex calculation and give a clear presentation of bridge analysis through simulation. Second, a lot more data is needed for FYP 2 as it is far from reach of the main objective of this study. Third, FYP 2 will be focusing on HEC-RAS as HEC-RAS offers a lot more benefit than HEC-HMS, and it can also be integrated in software such as AutoCAD Civil 3D. Last but not least is future work and Gantt chart for FYP 2. So future work, installation of HEC-RAS. It is very important as we need to learn how to utilize HEC-RAS modeling software for simulation. Next is to collect data from real study case as it will act as a guideline for a proper use of HEC-RAS modeling software. And we have to do simulation of dam bridge using HEC-RAS. The data will be collected from local source or supervisor. Next is my Gantt chart for final year project 2. I have distributed into 6 main points. First point is secondary data collection. Secondly is data analyzation. Thirdly is formation of chapter 4, the result. And fourth, the formation of chapter 5, conclusion and recommendation. Fifth, formation of final report for FYP2, and then lastly, the preparation of final year project 2 presentation. That's all from me. Thank you.